Alright, before we start on squares and rectangles, let's do a little bit of revision on perpendicular and parallel lines. You have seen perpendicular and parallel lines in primary 3 before, just that some of you might have forgotten about it. We actually did it in semester 2. Alright, so we're going to look at perpendicular lines and parallel lines again and see what makes them perpendicular and what makes them parallel. Okay, so what you see here is one set of lines. You have lines A, B and lines C, D. Alright. Some of you can straight away tell me that this is perpendicular or maybe this is parallel, okay, based on what you know. But don't worry about that. Let's learn again and let's see whether what we learn now is the same as what we learned from last year. Okay, so look at this pair of lines. Okay, you realize that based on just by looking, you realize one thing already. First, do you realize that they actually meet? Okay, you realize that AB actually cuts CD into two parts. Okay, when a line crosses each other, this is what we call meet. Okay, meet is also like cross. Alright, let me just write it down. Okay, when two lines meet, they actually cross. Or sometimes they don't cross, they just meet up to here, that's it. This is also called meeting. Okay, as long as they touch each other, they either touch each other or they cross it, this is what we call meet. But they don't just meet anyhow. They don't just meet in any way they want. They meet in a very special manner. And then if you still remember, last year we used this device. And who knows what this device is? Or this thing is? Yes, it's a set square. Okay? We're going to use a set square to measure or to see how they meet. Do they meet in any way they want to or in a certain way? So let's use our set square and see. Okay, you realize that when I put my set square at this angle, you realize, hey, the sides of the set square falls nicely on the lines. You realize here, the lines from A until this point is lying along the side of the ruler. Same here as well. Line from point C all the way to the angle here is lying along the side of the ruler as well. So you realize when you have this kind of thing happening, when you use a set square and it fits nicely at this angle, this is what we call a right angle. And I taught you last year, whenever this kind of thing happens, you mark it with a right angle symbol, which is like that. So what happens is that for lines that meet at right angle, okay, for lines that meet at right angle, okay, for lines that meet at right angle, these are what we call perpendicular lines. Okay, so perpendicular lines is essentially or basically lines that meet at right angle. Okay, and when they are perpendicular lines, in maths we have maths language, like in Chinese you have Chinese language, like Malay and Malay language, but in maths we have maths language. So when we want to describe lines that are perpendicular, we use the perpendicular symbol, which is just an inverted T like that. And can you feel these two for me? Which line is perpendicular to which line? Alright, I have AB perpendicular to CD. Of course, it can be the same the other way around. I can also put CD perpendicular to AB. Okay, the sequence doesn't matter. But can I put this? Sorry, this is BD. Can I put this? Okay, this is wrong. Okay, because this by itself is not the line. This by itself is not the line. Okay, we don't have a line AC. Okay, we don't have a line AC. We only have a line AB. Okay, so of course I can put AB first or CD first. It doesn't matter, but I cannot interchange the alphabets any way I like. Okay, it must follow the line. So basically, what I want to show here is that when you have lines that cross each other at right angle, they are called perpendicular lines. So basically, perpendicular lines that meet at right angle. Very simple. And how do you check? You use your set square. Okay, you put here is right angle. If you put over here and measure, yes, it is right angle as well. If you put over here, right angle as well. And if you put over here, right angle as well. So basically, once it meets each other at right angle, all the rest of the angle will be right angle as well. Alright, so this is for perpendicular lines. Because other than perpendicular lines, we have also another line called the parallel lines. Okay, so let's spend some time on that to revise. Okay, now you have two lines, EF, GH. First thing you see, just by looking, comparing it with perpendicular lines, ask yourself, do these two lines meet? No, they don't. Okay, they don't meet or they don't cross. Okay, it's the same. Okay, they do not meet. They do not cross each other. Okay, so does it mean that lines that don't cross each other means they're parallel lines? Of course, not just that. There must be other criteria, other ways to tell that they are parallel lines. You also realize that besides that they don't meet. Okay, if you're gonna draw a line longer, you realize that both probably won't meet. But what is another factor? Okay, you realize that if again I use my set square and I draw a perpendicular line from one line to the next. If I draw a perpendicular line, something like that. Okay, then I know this is right angle, and I draw another one right at the end. Again, this is perpendicular, and I measure the distance. Let's just do a small activity and let's just measure the line. This perpendicular line. Okay, this is around, I would say 2.1 cm. This one also same, 2.1 cm. You realize that one other thing about parallel lines is that besides not meeting each other, they also are equal distance apart. Okay, when I mean equal distance, I mean the perpendicular distance is the same. So parallel lines have equal perpendicular distance apart. Okay, so first is that parallel lines do not meet. You can draw longer over both ends, they will not meet. And why do they not meet? Because they are always separated by equal perpendicular distance. Okay, it has to be perpendicular distance. You cannot just measure like that and then you realize it's then you realize it's like 3 cm plus, and then you measure like that is 2.1, and then you say, teacher, it's not the same distance. No, I'm actually talking about the perpendicular distance. The perpendicular distance using your set square must be the same along the line. Okay, it can be at different points of the line, but the perpendicular distance must be the same throughout. Okay, and so basically at this point of time, you need to know that parallel lines never meet. Parallel lines have equal perpendicular distance apart. So again, in maths language, okay, we can describe parallel lines with mathematical symbols as well. Like English, we use a different language. Like maths, we use a different language. So for this case, since we know these are parallel lines, okay, the symbol we use here, okay, is actually 2 slash. Okay, it's not 2 straight line, it's 2 slash. So again, fill this for me. What line is parallel to what line? Okay, so most of you have seen it again. EF parallel to GH. Okay, of course it's the same if you flip it around. EF. Okay, it doesn't matter the sequence. Sequence doesn't matter. But can I write this? Okay, this is obviously wrong. Okay, because there's no line EG. There's no line FH as well. Okay, so I can interchange the position, doesn't matter, but I cannot interchange the different alphabets. Okay, this is totally wrong. So what I've seen so far is that for perpendicular lines like this, they do meet, they do cross, and they meet at right angles. Okay, how do I check? I use my set square, and the symbol I use is a inverted T. Okay, for parallel lines looks like that. They do not meet, they never cross, they never meet, and they have equal perpendicular distance apart. So if I use a set square and I measure the perpendicular distance, they are always the same. And for that, I use a double slash to represent parallel lines. And this is all for the revision part. So after this, do your running revision on perpendicular lines and parallel lines and angles, and then we'll start on squares and right angles.